Okay, let me get started. This is the last lecture, so that is good. What I wanted to just make sure we talk about the logistics before I'll get into issues about big data and things like that. The first thing is that we have a final exam. I didn't look up the exam date actually, so I don't know if anybody has it with them. It's on the syllabus.
14th.
What, the 14th? So the final exam is going to be December 14th. And does it have a time? It should say so on my syllabus too. What's the time of the exam? What? 8 a.m. Okay. So the final in here is going to be on a remote. It's going to be on remote because we don't have a room big enough for everybody. It's going to be a remote thing using the Respondus lockdown browser. Okay, if you took classes last year here, we used this browser, and when there wasn't live teaching, and it does things like it requires you to sit there and have a camera. It requires you to, it's watching you for signs of, doing anything like consulting a book or a phone or anything like that. And so the final is going to be, 12. My book has 12 chapters in it, as I remember correct. And I'm going to be giving the equivalent of one problem per chapter. Okay? It might be an exercise in the back of the book. I wouldn't put it past me. It might be another exercise that I make up on similar material. I wouldn't put it past me. Okay? So the way that I would study for the final is that I would be reading through the book. Okay, I would be looking at the kind of problems in there. I will tell you that my strong bias is on problems that have what I'm going to say, firm answers, so that that there's less debate about sometimes there's less debate about if I say what's the right way to do something. It's possible different people can have opinions. So if I have, I like quantitative problems. I like things that have one answer, as opposed to maybe softer problems. But again, it wouldn't put it past me to put on some softer problems on there. But the problems are typically going to be short answer. So there's going to be 12 short answer problems. The One of the unfortunate things about dealing with the browser is that it will not allow you to go back on a problem. So in the olden days, when you had written papers, some people would probably look around for some easy things to fill in, and then they'd go back, and then you're going to get the problems in random order. Everyone's going to get them in a different random order, okay? And you're not going to be able to go back, okay? So that means that you enter your answer and you move on, okay? Any questions about that? Now, the exam is, if the exam, I believe, is scheduled legally for something like 2.5 hours, if I am correct. Now, if you have 12 problems that you're going to be doing in 2 hours, how much time are you spending per problem? Okay, this is first numerical problem here. Okay, if you were doing it in 2 hours, how much time would you have? 10 minutes per problem. So are you supposed to be sitting here and writing a novel? You're not supposed to be writing a novel. You're supposed to be solving it. You're allowed to have 2 sheets of blank paper for scratch paper. Okay? You're not allowed to have notes or anything else on that. Okay? And so when you sit down, you show your scratch paper, both sides, to the browser, to the video, and then you can proceed working on it. Any questions about the nature of the exam? Okay. And again, at 10 minutes, remember, if you finish 10 minutes per problem, we'd still finish early. Okay. But on the other hand, that's the right order of magnitude. And generally, in the past, most of my students who've taken these exams turn them in early. Okay. So it's not, it's not like there's a race to the death. But understand that with the browser on there, it throws timing off. Any questions about the final or what's going to be on the final? Yes. Will there be what? Will there be multiple choice questions? The answer is no. Everything is going to be a written short answer type question. Okay? And, there might be numerical things, in which case you should be typing out as much work as you can so that we can understand what you're doing. But there will not be a multiple choice question. Any questions? Okay. Now, because using the browser is something that I am terrified of, because, wait, hold on. Will you need any tables or values or anything like, okay, hold on, now I'm seeing some questions. Hold on, chat. Okay, so do you need calculators? Whether you need them or not, you're not allowed to use them. So the hope is that you're not going to need calculators. The hope is you won't need calculators, but you're not allowed to use calculators. Okay? So I do not expect people to, again, a certain level of arithmetic is still acceptable in here, even if it's done by hand, but no calculators. What happens if you lose connection? Okay, the first thing I recommend is that you don't lose connection. Now, how do you not lose connection? Well, one thing is you go to a place with reliable internet. Okay, it might be that if your home internet is bad, okay, then maybe there's other places on campus or anything like that. Okay, so I encourage you to give some thought to where you take the exam. If you lose connection, can you log back in? The answer is yes. What will happen then? Well, hopefully something good. Okay. Um, you know, the TA and I will be live during the exam, and we will be monitoring things and trying to basically help you if you get into some trouble. But but so I will presumably have the office hour video link on, okay? But I don't want, but try very hard to get to a place where there's reliable internet, okay? Any questions? If it looks like there's going to be a hurricane or something like that that's going to take down the internet, travel someplace else before that. That's my hope. Okay, any questions? Okay. Will you need any tables or values like the PDF of the standard normal? I won't be assuming anybody has anything that I think you need. I will be giving you. Does that mean that I am not, PDF of the normal distribution? There's certain values of what the PDF for the normal distribution looks like that you should know about. Okay, and that I would be willing to, to do that. But anything you need, I will give you. Okay, you're not allowed to use a calculator. You're not allowed to use notes. Okay, any questions about that? Okay, so what I'm going to do, because getting to use the lockdown browser, I strongly encourage people to do a test of their browser beforehand. And we are running a kind of, I will say a practice or demo final. This is more a technical test and get you experience taking it rather than to give you ideas of what questions are like. I've told you what the questions are like. They're like problems like the, that would appear in the book, in the book as a homework or something like that. But what the practice final was sent, details were sent about over Piazza. Is that correct? That is at 1 p.m. tomorrow. Okay? If it's possible, I strongly encourage you to show up and try to take the practice final live. First, it will make sure that we're debugging things from our end also. Okay? If you're discovering, hey, your camera doesn't work, your browser doesn't work, we can potentially work through that, okay, live on the practice final instead of doing it. The practice final will remain online and open for you to take again if, let's say, it takes you a while to get your configuration working right. But I strongly encourage people to try to make the practice final, if they can, tomorrow at 1 p.m. Okay, any questions about the practice final? Okay. The other issue, let's say, homework 3 grades, I believe, came back. Is that true? Okay, so there was what do we call it? The rubric was posted on Piazza. The correlation with the first homework was good. It was something like 0.55, if I remember correct, which is a sign that the grading was somewhat consistent. You would expect that homework 2 should be somewhat predictive of homework 3, but obviously they're different papers and there's going to be differences. Any questions about homework 3? Okay. And the final thing is the project. The project is due tonight at midnight. That's what we agreed on. And everybody should be turning in a report. Every group should turn in a report of at most 8 pages plus references. Okay, you're allowed to use the fancy. Well, at one point there was a set of macros posted that were double column. You're allowed to use that if you want. You don't have to. Okay. But that's that. Any questions about the final project report? Okay. Any questions about the project report? Okay. Based on this, then, what can we expect after? Is a template not required? The text template is encouraged, okay? Meaning what? I think that the template has certain advantages. You probably can fit a little more text. You could probably fit a little more text with that template than the normal, 8-page thing. But I am not going to, enforce templateness. Nobody should take off if the guy, if you got a paper that was 8 pages but didn't use the template, unless they're doing something incredibly weird. If the paper's microscopic, if it's, something weird. But any questions about that? If so, what can you expect? Shortly after, on Friday, probably, hopefully, you will get a set of 3 papers to final papers to review, like we have done before. Okay, and we will, that as part of the peer grading. You will also get afterwards, at some point, a form for every person to rate the percentage contribution of every member of your team. So this is something that if they are consistent across individuals, this is good. If they're not consistent, if they're inconsistent enough, we will go, contact the individuals and track down what the story is. So it might be good if you and your partners kind of agreed how you were dividing up 100% of the project based on effort between you and members of the group. Okay, but these will be graded in. These will be received and processed independently. Any questions about that? Okay, if not, good luck at this time of year, which is obviously busy for everyone. Any other questions about the logistics of the course? There's no more logistics. I would like to talk about the last topic of the semester, which has to do with kind of big data. When I started teaching this course, big data was the buzzword in, everybody wanted to study big data. Everyone thought that, big data was the exciting thing. I think this is a buzzword that's less popular these days. I don't know how often people talk about big data, but it kind of captures the idea that suddenly there were really massive data sets to analyze. It's reasonable to say, give me all of Twitter, okay? It's reasonable to say, if you are a company like Google, give me, do an analysis of all the search queries made over the world. In bioinformatics, we are now at the point where thousands, actually many thousands of people have had their genomes sequenced. And each genome is 6 billion base pairs, trying to, make sense of what can you learn about health given the genomes of thousands of people. This is a big data problem. And generally working with data obviously gets harder with size. Again, my hope is this semester, most of what we learned were ways of working with what I'm going to say modest sized data sets, okay? But we should be aware of the challenges with bigger data sets. And when you say, what is a big data set? Well, data sets keep getting bigger and bigger with time. When I made up this slide, okay, which was back about 5 years ago, Twitter had 600 million tweets a day. And, there certainly are people who analyze all 600 million. Google was at that point serving 3.5 billion search queries a day. I'm sure that's a lot, that's much larger now. At that point, Instagram had 52 million photos uploaded a day. I'm sure that's wildly larger now. Okay? But these are, these are big numbers, okay? But obviously these are data streams that have a lot of information in them. And we would like to, it makes sense to want to analyze them for a variety of different reasons. Any questions? When people talk about talked about big data, okay, the buzzword associated was that big data had 3 V's associated with it. What was a V associated with big data? One issue in big data sets was velocity. There was a question of how often were you updating this data, okay? Sometimes you're dealing with batch data analyses. Sometimes you're dealing with live data analyses where you want to know what is the hottest thing. Obviously Twitter wants to know what's the hottest thing trending on Twitter in the last, 5 minutes. In order to do that, it's got to kind of keep up with this, feed in real time. So there's velocity is an issue. How fast is your data coming in and changing? Volume is the most obvious issue. How big is the data set that you're getting? Are you talking about gigabytes? Are you talking about terabytes? Are you talking about zettabytes? People, depending upon what your world is, the volume is, varies on over a big range, and the bigger it is, the harder it is to work with. Another issue about big data sets is that what they would call variety. One thing that's true is that most of what one thinks of as kind of data sets these days. So I like to think of data, my simple world is I like to view it as a table. I've got rows and I've got columns that are features, and all the worlds are matrix. With many data sources, it's not a matrix, okay? If you think about Twitter, what is the data you get from Twitter if you were analyzing Twitter feeds? Obviously, you're getting 600 million, text messages a day. But you're also, for a lot of them, getting photos, okay? You're getting links to other sites, okay? It's not just text. It's that there's essentially there's links, okay? You're also getting metadata. You know about who the guy who posted this tweet was, and you know how they're connected to other people, okay? You know who's following them. You know who received the message. So typically, we have a heterogeneous data source. Many of the things that generate big data are heterogeneous things, okay? And that's something else you got to deal with. Now, one aspect of thing that's important to realize about what people usually think of as big data sets, the kind of things that emerge in, the internet companies and things like that, is that big data sets typically arise as a result of, they're kind of a byproduct of some kind of a system, rather than data that was designed to be collected in the first place, okay? If you are Google, the reason Google runs a search engine is not to gather data about what queries are made, okay? Google says, my God, once it's getting the queries, the thing is, my God, this is a resource. I got to do something with it. But, in general, if you really have a question to answer and resources, money isn't a constraint, typically there are special purpose ways you would go and get this data. So, for example, I had a startup for a long time that was trying to determine public opinion about companies and things by analyzing tweets, okay? And if you really had enough money that you wanted to understand what the public was thinking about something, what would be the right way to do that? So one of our companies was Toyota. What if you wanted to really learn what the world was thinking about Toyota cars? What would be the right way to get that information? You could ask them. Okay, so surveys are a way of getting at this question, directly. Okay, if you take 1,000 random people, or 10,000, or 100,000 people, and you sit down for an hour and have them talk about Toyota, you will learn something, and you'll learn the right answer. Now, on the other hand, you might also say, well, are the tweets about Toyota good or bad? Okay. Are they saying, I like this car, or it's a terrible car, or something like that? Um, you know, it's obvious we would like to do something like that with Twitter, because Twitter's all this resource, there's all this data out there. Recognize that because we're using it because the data exists, not because it's the right thing inherently to solve our problem. And what makes big data potentially bad data? Okay. One thing is that it tends to be there's usually biases in who is using it. Okay. So, for example, if you're analyzing the sentiment towards Toyota cars, if you're using Twitter data for this, what are your inherent biases? Well, it's got to be people who like to yap on Twitter, okay? And I believe that people on Twitter tend to be more educated in general than the population at large. They are historically younger than the population at large. That may, it's probably less true the older Twitter gets, okay? But people's my someone's grandmother is probably, or grandfather is probably less likely to be on Twitter than the grandchild. Okay? So there's a problem of bias, okay, when you analyze it. There are usually big problems with spam and machine-generated content. You know, some people, one of the projects in here this semester was on analyzing Twitter to try to capture people's sleep cycles. And one thing that they noticed is, oh, some of these things are tweeting in the middle of the night. A bot, a computer program that's a bot that is just every 24 hours or every hour going to emit something. Bots don't sleep, okay? But a surprisingly large fraction of stuff on Twitter is machine generated, okay? And if you're trying to understand the opinion of what people are thinking, trying to figure out who's a real person, okay, becomes an important issue, okay? Typically, what you call it, when you are dealing with, you know, phenomena like, let's say, like social media, like Twitter as an example, there tends to be kind of power laws. If you did a plot, let's say we did a plot here, if we said the number of people emitting a certain number of tweets per day, what do we think the graph of the number of people as a function of how many tweets they emit are? Okay? We imagine that probably there's a very large number of people who emit 0 tweets a day, or very, very close to 0 tweets a day. It is, you know, the more tweets per day you have, the fewer people doing it. But if this is power law distributed, there are going to be a few people or sites or bots that are going to account for a large fraction of what is going on. There tends to be a lot of redundancy. Okay, if you wanted to keep track of it, a surprisingly large fraction of the tweets will be emitted by a surprisingly small fraction of the users because there's a power law thing. And that means that there tends to be a lot of redundancy. Okay? Any questions about it? So, you know, analyzing these ambient data sets is good. It's important to understand where there are limitations of that. Any questions or discussions? Yeah.
One more issue about the changing of the opinion. Like, let's say that some famous person tweets something about a particular company, or yes, so people in general start believing that even though they know it's not true, but for some period of time until they realize.
Okay, so the question of if we were doing opinion mining on Twitter, there's a question of how do you capture when things change, okay? And so, you know, the hope would be that if you have, you know, you want to analyze the tweets from every day, and the hope would be that you see kind of trends, okay? So when we were, you know, I'll admit that when we had a company that was doing this, and Toyota was a customer of us, and they had a problem where their brakes on the cars weren't working. And if you looked at the sentiment for Toyota as a function of time, people thought Toyota was great, then they discovered the brakes stopped working, and then after a while people started talking about other kinds of things. So, you know, the hope there, as far as understanding the trends, certainly if you're analyzing the accumulated of all the tweets since the beginning of time, events, that something like that is not going to react quickly to changing news. But the hope would be that if you analyze it on a you know, regular basis, again, it was a live thing, you were analyzing the live feeds, the hope would be that you would see statistical changes, statistically interesting changes, and that would occur with time. Any other questions? Now, when it comes to machine learning, we like, big data. We like having a lot of data. Now, one thing that's known generally, the algorithms we have used in this semester have, involved relatively few parameters. And if you have big data, on one level, the good thing is that you have large training sets. The bad thing is that if you have models with relatively few parameters, you can't really benefit from large training sets. I mean, there's a point at which the model's going to be saturated. If you're going to try to do a linear fit and you have a small number of dimensions, if the model is any good, having 1 billion rows isn't going to help you train a much better model than 1,000 rows. Okay? So, that's one of the reasons why, deep learning methods, which do use a lot of data, have become important in natural language processing and image processing and things like that. One other advantage, though, of large data is, in general, having a lot of data to train one model usually is overkill. But on the other hand, having a lot of data to train many models is actually often a good thing. Customization, like what does Google do with all your query data? When you search Google, okay, you don't emit a large number of searches. I'm going to guess that on the average person here has put in on the order of hundreds to thousands of queries into Google. Okay? That's not enough to train a huge model about the way the world works. On the other hand, it is probably enough to do some level of customization for you. Okay? And so one of the ways that you can take advantage of big data is often, it can have some contribution to a big general model. But the better way you can often use it is to train many, many different models through customization, basically building a model for each person, okay? Which you can get a modest amount of data on each person only if you have a huge amount of data on everybody. Any questions? Now, one of the best things that you can do when you have a lot of data is you can throw some of it out, okay? That if data is, a cheap enough resource, okay, one thing that's done is you can, use it to make data cleaning a lot easier or a lot more effective by throwing out, the stuff that's harder to analyze. Again, we were trying to analyze public sentiment in Twitter, okay? Our customers were generally generally companies interested in the US market. When we were looking at this, only 34% of all tweets were in English. But obviously, if I wanted to try to do sentiment analysis, it's a lot easier to throw out all the non-English ones. If English is the most important single language on Twitter, okay, it's easier to throw out, everything that's not English and do a good job analyzing English rather than try to do a job analyzing individual languages. And so filtering out, knowing what to throw away, one level of filtering is to use your application knowledge to figure out what data is going to be harder to analyze, what data is less relevant to my project, okay, and try to use that, and try to get that away. But that tends to require sort of an application-specific knowledge. Here, knowing that English is different than Spanish which is different than German and stuff like that. Any questions? The idea of, so if you have a huge data stream and you want to get it down to a more modest size, one thing to do is to throw away the stuff you know is going to be hard to analyze. But even then, you may very well have too much data at your disposal, okay? And subsampling, figuring out what to actually throw out, okay, how to take a sample of your large data, okay, so that you get a smaller amount of stuff to work with, is a generally useful thing when you're working with large data sets. We've shown in here that we talked about when you're building models, you want to be able to separate training, testing, and evaluation data. That means that you want to partition your input data into different chunks, okay? And, there's different ways you can do the partitioning. And the idea of how to do data sampling right is an interesting question. So suppose, let's say, we are given a giant data file of n records. Maybe they're tweets, maybe they're Google queries, maybe they are something else, okay? And let's say we want a small chunk of them to analyze. How can we go, and what are ways that we could take our file of length n and come up with k records, okay, from that, okay, that are chosen in a principled way, okay? What is the right way to sample from a big file? Now, the simplest way would just be to take the top k rows, okay? What is good about taking the first k rows as our sample? Is there anything good about that? Okay? One thing is it's simple. One thing is it's reproducible. Okay, if I want to go and do this experiment again later and wonder how I got it, if I knew I sampled the first k rows of this file, that's enough to reproduce these things. Now, of course, there are biases, however, if you take your data and just take the first k records as your sample. And some of these biases, I think, are kind of interesting. It has to do with what is the order in which the rows appear in your input file. If you're dealing with log data or something like that, often the rows come in temporal order. If your file was built by just appending new rows to the bottom of the file, what happens if you take the first k rows? You get the oldest data, okay? So that's not a good thing necessarily. What if you have the elements sorted by, let's say, by name? If these were people and they were sorted by name, what kind of biases would happen if you took the first k names in sorted order? Are people randomly kind of distributed if we take it by sorted order? Okay. One thing I have noticed is that Arabic names often begin as al somebody. Okay. And I may be wrong about this, but my sense is that Chinese names don't tend to start with A. Okay. Maybe I'm wrong, but there tend to be biases in this thing. Certain, if you take the names in sorted order, you will probably create different ethnic biases, okay, among things. What if we take people and sort them by their social security number? Every one of you, I think, has a social security number. Is that right? Or you don't have a social security number, I guess, until you're working. You have a university ID number. Okay? Anyone in the United States who works gets a social security number. If we sort people by their social security numbers, and we take the first chunk of that, what kind of biases would we get? Okay. Well, it depends upon any weirdnesses of how they assign social security numbers. It turns out that the first 5 digits of your social security number will encode what state you were living in when you got your social security card, and when you actually got it. Okay. So it turns out that the last 4 digits are essentially random. The first 5 actually encode information. So truncating it is a bad way to do that. What is another way to create a sample? If I give you n records. Okay? Is there any other approach to getting a sample of that? Randomly choose k things. Now, how do you choose k things? One possibility is that if I have n records and I sample them each with probability k over n, with a probability of, I'm going to flip a random number generator, and I pick for every record, I say, are you, I flip a coin independently with probability k over n. If it comes up heads, I'm going to take that record. If not, I'm not. What happens then? The expected number of records I get is the number of records times the probability of sampling. I would have an expectation of k records. What's good about that? There is certainly no explicit bias. I'm not going to be biased, at least at the beginning, okay? I'm not going to be favoring explicitly any ethnic group or any time period or anything else. But there are problems with random sampling. One is that there is going to be still some kind of discrepancy. Suppose I have a file of n people, and n over 2 of them are male, and n over 2 of them are female. And I sample k records here. Am I going to get, okay, let's say even if k is an even number, will I get the same number of men as women in my random sample? Almost certainly not, okay? And this can actually cause a problem. Suppose, let's say, my understanding is that men tend to favor Trump more than women do. Let's just say that I believe that's a fact. That's not, neither good nor bad for anybody. But what does that mean? If you wanted to conduct a poll of k people to decide who is going to support Trump, okay, whether people are supporting Trump or not, if your random sample happens to contain more men than women, Trump's likely to do well. And if you had more women than men, Trump is likely to do badly. And if you have a close test, okay, the fact that you're not sampling the groups, certain groups will be oversampled and certain ones will be undersampled. That can come to bias everything that, make the results harder to interpret. Okay? What else is bad about this? Well, one thing that's true is that random sampling isn't really a reproducible thing. If you take a sample, okay, unless you had the seed of the random number generator you use, the seed in the random number generator, nobody else could actually reproduce exactly what sample you were working with. That's, given the original file. The other thing is, suppose you want to do this multiple times. Maybe you're going to want to call, let's say you're doing polls on the political polls, okay? And you're asking people now, and you're asking people again 6 months from now. If you'd like to get a random sample, if you do 2 random samples, odds are that some records are going to be in common in both samples, okay? And that is unfortunate. There's no guarantee that the samples are disjoint. Any questions? So what other sampling ideas do people have? There's an important idea that comes up in polling that is very important. Polling, if you think about it, is a world where they are trying to get opinions from people that are representative of a population. One way to do it, of course, would be to randomly sample the population, okay? But again, typically then, certain groups are going to be overrepresented or underrepresented. The idea of stratified random sampling is what good pollsters will use. What will they do? They will break down the population into chunks. Maybe they will have, male people who are young, male people who are old, female people who are young, female people who are old, okay? There are different, there's a certain fraction of the population that would fall in each one of these buckets. One idea, if you want to get a poll with the property that each group you care about is sampled an appropriate amount of time, one possibility is to say that if young men corresponded to 30% of the population, then what you would do is make sure that 30% of the people that you would take your universe of people, break them into chunks according to the demographics, and make sure that you sample the right number of people from each chunk, okay? So if you're doing a polling thing, typically there are ethnic groups people care about. There are gender balances, there are age balances. If you can break your population into these cohorts, and you know how big the cohorts are in the whole population, you can then sample your candidates to make sure you get a sample there that matches the population. That's what we mean by stratified random sampling. Any questions? What other ways can we sample? Okay. Sampling, I will claim, one that is a surprisingly good non-random way to sample. What happens if instead of sampling at random, okay, I start from some offset and then sample every, n over kth record. So they're uniform positions in my original file, okay? This has the property of being easy to do. I can go through my file and simply count. What line is it on? First line, second line, third line, ... Every kth line, I am going to pick out a sample, okay? If my starting point is going to be some number between, if I wanted to sample every mth one, my starting point I can have m possible starting points, okay? This is a surprisingly good way to sample, okay? It gives me the right number of records. It has the property that it's reproducible and it's easy. And I can ensure that my samples are disjoint, okay? So if I want to, let's say, go back and do it again, so long as I start at a different different, starting point, okay, I will end up with a different set of records. And this is a surprisingly sensible way to do sampling, okay, in its absence. This is what Twitter does. Twitter will like make public 1% of its tweets. How does it decide what tweets to make available? Well, it's the ones that are congruent to something mod 100. Any questions? The final sampling problem that I want to talk about here, okay, because it's kind of a cute thing and it tends to be something that appears on interviews. So for those people who are going to have interview questions, suppose I am going to have a stream of items coming in. Okay, so there's new items being created all the time. I want to sample, let's say I want to sample I want to sample 100 tweets that are going to occur today. I want to sample 100 of them. But I don't, at random, so each tweet is equally likely to have been called, okay? I don't want to accumulate the file of all tweets, though. You could imagine a world where storing all the day's tweets is expensive, even for Twitter. If I want to build, so I don't want to actually accumulate the whole day's tweets and then randomly sample 100 of them. What I want to do is to sample from the day's tweets without memorizing more than 100 of them, and knowing that I'm not going to favor any particular tweet, even though I don't know how many tweets there are in advance. Okay? You see what the problem is? There's a stream. At some point, they're going to say stop. Okay? And I'd like to have had I'd like to have a sample of a given size that were random sample of the tweets I have seen without having stored all the tweets, okay? Only having stored a sample of size 100, which is small. Any questions about what the problem is? Okay? This is called stream sampling. We like to get a uniform sample from a stream, okay? Where we don't know what n is in advance, okay? How can we do that, okay? Again, the tricky thing is, if we don't start filling in a sample as we go along, okay, all the time, if we suddenly start, we don't know if there's going to be a total of 100 tweets or a total of 1 billion tweets.
कैसे show करूँ मैं?
Is that a question for me? I have a feeling someone's got their microphone on. But, so what is the idea? The idea for doing this stream sampling is that for the first K tweets, we're going to fill it in. If we have 100 slots and we only have 100 tweets, then we have to take all of the 100 tweets. Does everybody see that? If we have taken the first K tweets, what is the probability, if we had a total of K plus 1 tweets, that the K plus first one should be in that sample? Okay? In reality, the probability that this one should be included, okay? Let's think about it. If there are K slots that we want K random tweets, and there were a total of K plus 1 tweets that day, what's the probability the last tweet should be in there, in that random sample? Okay, there are K tweets going to be in. This tweet should occur with a probability of K over K plus 1. Okay, so 1 over k chance it's not going to be included, which means that there's this probability of it being included. In general, what is the idea? Well, for each new tweet, we're going to say for the nth tweet that come along, we are going to add it to our random sample of k with probability k over n. Okay? And if we do decide to add it, we're going to throw one of the other k tweet. We have to throw one of the other k elements out at random. If we do this, we will end up getting a fair sample. Okay? Again, the probability that something is going to survive, that you end up getting sort of a canceling, a product of things that cancel properly. And the probability that any particular element survives turns out to be k over n. Okay? So sampling from streams, there are clever algorithms with the property that even if you don't know the size of what you're looking of your uniform in advance, you can build an online sample in a statistically rigorous way. Any questions? Okay. What other things are there? So sampling, so what can we do with large amounts of data? One thing we can do, as I said, is throw the data out. Another thing that we could do is basically try to marshal the computational resources in order to do this, to process all of it. And this gets us into issues of, again, distributed and parallel processing. I think of parallel processing as kind of what happens on one machine. This is issues of things like threads and operating system processes and things like that. Making use of the multiple cores on a machine. That's what I think of as parallel processing. Distributed processing is a world where we have many machines and there's network, these are connected by networks. And, it is harder to have tightly coupled computations in a distributed world than on a single machine. So what we would like is data processing where we can take our task, our big data file, break it up among multiple machines, and basically have all the machines kind of cooperate to process what we want to do. The easiest way to take advantage of multiple machines is what we would call data parallelism. You could imagine if you have one giant file of stuff that needs to be processed. If you can break it into chunks and have each one, a different computer, work on each chunk, that is the right way to take advantage of multiple machines, assuming you can move the data to each machine, okay? And assuming you can combine the results of the analysis cheaply, okay? Often it's hard to combine results. Often it's hard to take data and move it to different machines. A lot of big data type analyses, things like counting how, looking at the sentiment of tweets. Each tweet is going to be an individual document. What would you want to do? Analyzing it, is a kind of a local thing. You then want to take the combined results of all the analysis and aggregate it, okay, in a certain place. If you have big data and you want to move it to many process machines, if you have a big files on one machine, moving it to other machines takes time proportional to the size of the data that's moved. Moving data is expensive. If you have something like sentiment analysis or understanding what a tweet means, that's typically linear in the size of the data, okay? It's often hard to move things around and combine these things. So But on the other hand, if you do have, large data sets, obviously we're all familiar with cloud computing these days as a means of commandeering large numbers of machines. In order to use a large number of machines, okay, you need to employ some kind of an infrastructure, okay, some kind of a technique that can coordinate the large number of machines, okay, dealing with the fact that when you have large numbers of machines, strange things happen. Things get more complex, any process gets more complex the more entities you have that are involved in this process. One example that I find kind of revealing is how social gatherings change as you have larger numbers of people involved with them. Okay? If you want to throw a party, if you want to have a date with one person, this is easy to arrange. You call that person. If you want to have a small group, people can coordinate relatively easily. If you want to have a group of 10 people coming to an event, you need to identify a leader. If not, it's chaos if everybody tries to interact. If you're having a wedding with 100 people in it, you can no longer let everybody order what they want to eat. Okay? There's a reason why it's not too complicated to arrange that level of coordination. That's why weddings with a certain size have fixed menus. When you get to a really huge wedding, I've twice been at weddings in India with 1,000 people in it. Okay? One consequence of that is that nobody knows anybody at these, as far as I can tell, there's nobody who actually knows most of the people at the wedding. Okay? Because just too many people. If you have a social gathering for 10,000 people, okay, like maybe a conference or something like that, you'll find that very few cities can do this because there's not enough hotel rooms, okay, to hold that many people. And when you have a really large gathering, like let's say a football game with 100,000 people, one thing that you can say is almost certain that's going to happen is that somebody is going to die either at the game or on the way to the game or on the way home. How long does the average person live? The average person lives 100 years, right? At most, okay? 100 years is how many days? It's about 36,000 days, okay? If you have 100,000 people days, okay, you would expect that 3 of them are going to die during the course of that day. Okay, that's a rough kind of thing. So in trying to do any of these parallel things, the larger n is, the more likely there is going to be a problem. And that you have to kind of plan or expect that there's going to be a problem. Any questions about that? So what are these, the paradigms for using distributed processing? There are these systems that are based on the kind of Mapreduce paradigm that Google originally introduced. It's been taken up by systems like Hadoop, which is not a Google system. That is a way of kind of programming multiple machines in parallel, okay, for doing the kind of big data analyses people typically want to do, okay? What's good about them is that they enable you to have a simple programming model. That you're able to program, hundreds or thousands of machines without hiding a lot of the complexity. And one of the things that you hide that helps hide the complexity is fault tolerance. Just as 1 out of 100,000 people are going to die every day. If you have enough machines, one of them is going to die during the course of your computation. Being able to tolerate that is one of the things that you want from one of these systems. So what kind of let's say, big data type problems are representative, okay? Typically, if we have a large data set, we have a large number of records, a large number of files, okay? Typically, what we want to do is to look over each one of these records and, do something on each record. Maybe we want to count how, how many words were in it. Maybe we want to see if there's a person, place, or thing measure mentioned in there. And then whether people said good things about them or bad things about them. Okay? You want to do some kind of extraction of local things. You then typically want to aggregate, basically, the intermediate results. Okay? If, let's say, you wanted to count the sentiment of an entity, how people were talking about Toyota. You want to count for all the tweets that mention Toyota. What was the sentiment associated with them? The average, the total, something like that. And if you're doing this on a multiple machines, you want to aggregate this over all kinds of different machines. Okay? And then basically, prepare the final report, okay, that you would like to be able to do. This is typically the kind of thing that you would like to be able to do with large data files. And this is the kind of thing that Mapreduce processing is very good at. What is the kind of example here? We would typically like to take our work to be done, split it among many different machines, have each machine do something and produce some sort of intermediate result, and then combine the intermediate results. That's kind of what the principle of divide and conquer is. So how is it that Mapreduce does this? Okay, the key component of a system like Hadoop, there are kind of two different things that it does. One is it takes all the machines you have at disposal and it produces a shared, file system so that each of these machines can write and read from this shared file system. This is what we call the Hadoop file system, Hdfs. There is also a runtime support for this kind of Mapreduce primitive. Okay, how do we, basically spread the work among these machines, and how do we do the communication? That's what I'd like to kind of describe a little more carefully. Any questions? So what is the idea of Mapreduce programming? In a map function is essentially a hash function, okay? Given a key and a value pair, okay? Mapping it is going to produce, we want to be able to produce a hashed key and whatever value that we want to kind of store in it. Mapping is basically taking, let's say that for our sentiment world, okay, we wanted to know for Toyota, and we knew that on a particular tweet it had a negative sentiment, okay? Mapping it is going to involve hashing all entries of Toyota so they kind of go to the same place, okay? If we want to come up with a aggregated sentiment for something, we need to be able to make sure that if we have lots and lots of different machines processing sub-collections of tweets, we want to make sure that all the ones that involve Toyota end up at the same place. How do we do that? Well, mapping it basically says hash this value to a specific value k, okay, K is going to be the location in some sense in this file system where all the Toyota tweets should go. Reduce is going to be an aggregation process. After we have taken all of our records and hashed them to the right place, reduce is now going to take all the records on one machine and go through the file associated with all those records, okay, and aggregate it in an appropriate way, okay? So the basic world we have here is, in the input, we have a lot of data files to begin with. We have a certain number of machines, okay? Each machine is going to take one segment of the data file, okay? And in the course of mapping, output something to analysis where there's a key and a value paired. The Hadoop system is going to aggregate, okay, over all the machines in this sort of shared file system. Aggregate the records in buckets based according to their key. The reduce phase is then going to go through each bucket and do the appropriate aggregation for it, okay? And then if the aggregation, something like sentiment count, it produces a number from all the set of tweets, okay? The hope then is that each processor will have a small amount of final results, which it can then disseminate more freely. Any questions? So what is an example of Mapreduce for counting words? The typical mapping process. So let's say, and again, counting words is a lot like counting sentiment. If we know for each word, let's go back to the example of doing sentiment. For each company mentioned in this, each company that appeared in any tweet, if we had a sentiment number associated with that reference, what would we want to do in our map phase? What are we going to do whenever we find a new word of interest, meaning the company name? We emit a record, a pair that is the company name followed by with the associated number. If we were counting how many times it was mentioned, that count would be 1. If it was a sentiment score, if we wanted to accumulate the sentiment, we would say, what was the sentiment in this reference? The reduce program is simply going to aggregate these numbers, okay? Reduce is going to take as input, okay, basically a term, okay? And it's going to say for all records whose first value was that term, what are we going to do? I want to aggregate it by basically summing these things up, okay? And this is basically the program. Map says go through and send out records. Reduce says accumulate the records and produce the final value. Any questions about that? Okay. And again, this is basically the program you would use for doing the counting, for doing the sentiment aggregation in a big thing across many, many records. And again, the impressive thing is, again, how simple the resulting program is. What does a typical mapper do? For each record in there that is interesting, emit, okay, the key value pair. For the reducer, okay, for all the records that had that key, basically to simply count things up, okay? Any questions? And here's kind of an example in a world where we have text. There are 3 different mappers, okay? If we were trying to do word counting, each time we had a word, there would be an emit message done. The emit message is going to take the key and convert it to a hash code. Because it's using the same hash function on each of the machines, all the records are associated with a particular vocabulary word like the are going to get hashed to the same place. That place is going to be associated with one of the reduce processes. Okay? So all occurrences of the word the, wherever they occur, okay, they will get sent to the appropriate machine. The, it turns out, was this one, what was on this process, but was kind of on the first half of the partition. So the does will get sent here. The file system's job is to accumulate, okay, all of these emitted records. The reducer would then go through a record like this and count up how many times each word appeared in order to deal with that. Any questions? Okay. And you know, that I think is given the time that we have left, that's probably where I think I'm going to leave it. Except with the other thing that the Hadoop file system, again, is a clever, Hdfs was a way of trying to combine the RAM on many different machines, okay? You'd like to store the records itself in a disk. When you scan through disks, if you're processing disks sequentially, okay, going through files, chunks of disks at a time, throughput is actually quite reasonable. So again, the basic principle here is of fast scanning through of records, okay, accumulating. When we had emit command, when things got hashed, they got appended to the end of files. Then these immediate other processes would be scanned through equally. And I think that's where I'm going to leave it here. Okay. Any questions on, I know that was a fast overview. I encourage you to look at the book just to get a little bit of a sense of this. And if you're really interested in this, we do have a big data course that's taught every year where we get into the specifics of, large scale processing. Okay, are there any questions about the exam or any of the other technical things? Final exam will be on, we decided I think it is the 14th at 8 in the morning. Sorry, let's go back to the beginning. The final exam will be December 14th at 8 in the morning. Like I say, roughly one question from every chapter in the book is the way to think about it. Short answer questions, not multiple choice. And the questions may be exercises from the book. That's what I encourage you to do to study. Or they may be new problems I come up with. And quite likely will be new problems I come up with. And there is a practice final that will be Friday at 1 p.m. Okay, follow the instructions on the over on Piazza. Any questions? We have any coding kind of thing? The answer is no. I am not going to be making you program any Python. So that's not going to be something for you to worry. The questions will be conceptual or analytical, meaning you have to compute a number or something like that. Do some kind of analysis on. Any questions? Yes.
How long will the practice final be on the
How long will the what?
practice final? How long will it be?
The practice final, we are hoping, the practice final is 2 questions, which of course means 0 to your grade. So I encourage you to do it just as kind of a practice, just to get used to typing and trying to see how you explain such things. But I think we're only allowing 45 minutes for the practice final.
How many days? Like it starts tomorrow. From tomorrow to
It will start tomorrow. We will presumably keep it live till either through the final or right before the final. Okay, but I do encourage you to, if you can, go to take the practice final live, because kind of this way we can help debug what your system problems are. Okay, whereas we can't do it unless we're also monitoring this at the time. Okay, so try to get on there. Any questions? Questions about, am I going to have my office? Will we have office hours? I recommend I will probably be I will presumably be in my office during the office hours. If you really want to talk to me, it's probably good to give me a send me email just to check beforehand. Okay, but I think I will be there. Any questions? If not, good luck getting your projects in and with the rest of the semester and with the final. Okay, good luck and bye-bye.